what is UART communication? UART stands for Universal Asynchronous Receiver Transmitter. This is an asynchronous protocol. So in this communication, there is no clock line shared between the two devices. This communication only uses transmit and receive line. As this is an asynchronous communication and no clock is shared between the two devices, so here both devices must be configured at the same baud rate. Let's say device A operates at clock frequency, let's say a baud rate X. So device B should also be configured at similar baud rate. The tolerance of 10% is acceptable in this case. So here both devices will be running at same baud rate and it will receive the data from transmitter to receiver end. And if you see the data frame, so the actual data here, which is again configurable, you can configure this for each device. So as part of configuration, you have to first select the baud rate. Second, how many data bits you have to transfer. Let's say you want to transfer 8 bits. So at both sides, you have to configure the communication will happen for the UART with 8 bits at both sides. And you can choose whether the parity bit will be used or not. If you are configuring this as 1, means you are going to use this parity bit at transmitter side. So receiver side also you have to configure the same thing. You want to use the parity bit, and stop bit you have to select how many stop bit you want, 1 or 2. If you are selecting 2 stop bits, actually stop bit is logic high and start bit is logic 0. If you are selecting 2 stop bit at transmitter side, so receiver side also you have to select 2 stop bit. Let's see at block diagram level. Here both the device will be running at same clock frequency for the UART peripheral. So baud rate is same at both sides. So when let's say this device A wants to transmit data from here to device B over this TX line, so it will update this transmit register as per the configuration you have done for this data bits, how many data bits you want to transfer. If it is 8, then 8 bit you will update in this transmit register, and this transmit register will be again loaded to the shift register, and from this shift register it can be transmitted over this TX line. And to start this transmission, this data will be wrapped with a start bit, which is logic 0, and a stop bit. A stop bit is must. Either you have to select 1 or 2. A stop bit is logic high, and parity you can enable or disable. So let's say you have disabled this parity bit. So whatever data you have written to this transmit register, 8 bits, so that will be wrapped with a start bit logic 0 and a stop bit logic 1, and bit by bit it will be transferred over this TX line. And when it reaches to this receiver end, so there initially it was idle, the signal was idle, and for this clock this line has become low, which tells receiver that a new data has come and start receiving it. And there is the criteria for at least half of the pulse. This is a complete pulse, let's say. So half of the pulse, this signal must be low for the start condition. Then only start condition will be considered. Otherwise, it can be considered as some erroneous data and that will be ignored. So when this signal has become low for more than half of the cycle, that will be treated as a start condition. And after that, whatever data is coming for next 8 pulse, the configuration we had done for 8 bits, so all for next 8 pulse it will receive the data D1, it will receive the 8 bits data, and after receiving 8 bit it will expect stop bits. Let's say if it is configured for 2 stop bits, so 2 logic high will be expected here, and once receiver gets this stop bits, it will understand that transfer has completed and the signal will again go high, which is an idle condition. That's how the data is transferred from one device to the another device over the two lines using UART communication protocol.